I'm ready. Thank you, everyone, for the opportunity to give an overview here about renewable power. There are four major renewable power topics that we'll discuss briefly here today. Wind, hydro, solar, and geothermal that are sort of graphically depicted here in form. To start with, what are the guiding principles associated with renewable power? First and foremost has been cost reduction, efficiency improvement, reliability and durability improvements. The programs in wind, solar, hydro, and geothermal actually have their origins dating back to times before the Department of Energy had been created. There was work during the National Science Foundation ERDA program, Research for Energy Needs. And in these programs, a lot of progress, especially in the past decade, has taken place as costs have dramatically dropped and as proof points for the technologies have been validated. 40 years ago, we didn't have a proof point for most of these technologies being durable in the field. Today, we have many examples of wind and solar that have been in the field. In the case of solar, some for more than 40 years now out at Natural Bridges National Monument, still producing the same power that they did when they were originally deployed. It's great when we don't have moving parts in some of our technologies. We model the opportunities for the technologies primarily around levelized cost of electricity. That is, what's the value of the energy delivered over the course of the life of our products. In the case of solar, many of the modules in the field today have warranties as long as 35 years. On our next slide, we speak to some of the key elements for each of these four R&D areas that have roadmaps associated with each of the technologies so that we know if we work on an aspect of efficiency or manufacturability that it will have a consequence to that levelized cost of electricity. Those analyses then are also overlaid with mapping tools that can be used by the electricity grid operators, both at the transmission side as well as the distribution end of the grid. On the distribution side, much of the solar work on rooftops, for example, connects in with energy efficiency programs that help us both save electricity as well as generate new power. The progress that has occurred in declining costs on an unsubsidized basis in all of these technologies has been dramatic and almost exponential in nature for the past decade because the markets have scaled. For many of the technologies like wind and solar, it's been possible to start at smaller size in rural areas and build markets that have supported manufacturing scaling. For all of these technologies, as well as, for example, energy efficient lighting, the rate of progress has been phenomenal, and now the amount of solar and wind installed into the grid, for example, over the past year in the U.S. has exceeded energy from other electric generation sources. One of the things we're especially pleased about is the more than 500,000 jobs that now exist in our renewable power portfolio here in the U.S., and these jobs are growing at a faster rate than the economy as a whole. In the case of solar, we add over 1,000 new jobs every week, and most of these jobs are in the project development and installation side of the value chain, where average wages across the entire U.S. are in excess of $26 an hour. So we have good, non-exportable, high-paying jobs that are coming along with the rate of adoption of renewable power. For our selection of prioritization and the creation of targets with technology goals, we have mapped quite sophisticated cost models for understanding how each component fits into a system, what system reliability requirements we must have in order to meet that longevity standard. Much of the challenge in our industry is really centered around financing because the cost of capital, most of these kinds of products generate power well into the future, but need to have funding today for those construction projects to be made available and viable. In addition, as these technologies scale, the access to the grid becomes increasingly important, and the ability for the grid operators to correlate forecasting tools with the performance expectations that can be projected out as far as a week in advance and as short as 5 minutes ahead. Most of the innovations that are happening in the scaling of this industry relate to new and creative business models that are being developed by our utility partners. In the case of solar, there are 3 primary areas of activity: photovoltaics for the direct conversion of light to electricity, concentrating solar, which makes use of fields of mirrors to shine light on a fixed point that goes to much higher temperatures to generally fluids like molten salts that then transfer their heat energy through heat exchangers into oftentimes steam turbines, not unlike what are used in natural gas, coal, and nuclear power plants. The bottom graphic basically shows the modern grid, where generation of many different varieties connects into the transmission grid, and through that to substations and then to feeder lines. What's unique today is that two-way power flow is possible on the distribution network, much like the advancement of Uber and Lyft for better use of our road infrastructure. We are able to make better use of the existing wires by being in a position to have power flow 2 ways and to be managed by the high-speed communication capabilities that now exist. All of these lead to customer participation in the marketplace, making choices about when to use electricity or maybe even when to deliver electricity back to the grid. And of course, all of these points of connection make cybersecurity ever more important each day that goes by. In the case of our overall energy resources, we're happy to say that not only has the scaling of solar and wind expanded to the point of becoming the largest fractions of new electricity additions, but that we serve stakeholders all across the bipartisan spectrum that exists. And voters in all parts of the country have indicated their desire to have more energy choices, and in the case of solar rooftop systems, to be autonomous or at least self-reliant in the amount of electricity that they use. An example of the kind of technology road mapping that is in place is displayed here in the SunShot goals for 2030. SunShot is an initiative that started in the Department of Energy in August of 2010 with the objective of seeing utility scale power reach 6 cents a kilowatt hour by 2020. Today, we're almost already there at 7 cents a kilowatt hour in an average climate like Kansas City, as is referenced here. And you can see the span of the cost of power from solar in a very sunny area like Daggett or a less sunny area like Seattle. it varies by about plus or minus 1 to 1.5 cents. So solar works everywhere. We have technical details to support initiatives to increase efficiency, to increase reliability, to minimize the cost for deployment, the structure, the effectiveness of getting more kilowatt hours for every peak watt. And by having an understanding of those sensitivities, we've created a roadmap to cutting the cost in half again by 2030. And in December of last year, we announced our 3-cent per kilowatt hour target for utility scale photovoltaics. And I'm pleased to say that we're seeing already continued progress in this direction. I want to thank you all for the opportunity of speaking here today.
Thank you, Dr. Charlie Gay. Do we have any questions from the audience? I'll give a little time for submission, and if we don't get anything, we'll move on to the next speaker.